Hi everyone, here I'm recording the labs for the traverse computational adjustment, how to adjust the traverse with our field measurements. So let's start here. I have a spreadsheet here. I'm going to share that with you in a second. Let's assume that this is the traverse here, and I'm showing you here some of the measurements. But let me get to the field notebook. So this is what you should have after you get your field data. Let me get to spreadsheet here. So this is what you should have in your spreadsheet. Let's go over it. And I'm just using here the odd number traverse 101 through 111. So let me zoom in here. So what you did in the field is you went to every point and then you collected degrees, minutes, seconds. That's the first trial. I'm going to highlight it maybe with yellow. So this is your first trial. And at each point, if you remember, I asked you to collect the angle twice. So this is the angle the first time, and this is the second trial. That doesn't mean we did the traverse by going twice over the points. No, at the same point, we collected the angle 2 times. Zero it. If I'm just using the whiteboard here, and assuming here I am at, okay, 1, yeah, here we go, text. This is 101. So if I'm at 101, I will be looking at the next line here, okay? Sorry, the next point with this line, and backward at another point. So the next point in this case, and my sketch here is not to scale, so 103, and looking backward, I am looking at 111. Okay, so while I was at 101, I did the following. Now I'm recording this, by the way, before the lab, but hopefully that is what we will do in the lab this week. So today, well, I don't want to give days so that you don't get confused. Okay, so just going back, I am at 101 with my equipment on the point. Remember, on the point, I zero it at 103, got this angle, which is my 78, 1724. At the same time, I also got the distance, the first distance, which is what you will see in the spreadsheet as 136.50. So this is the distance here, and I also got the other distance, 101,111, so 263.89. So that's the first trial here. And then at the same time, you measured it one more time. So let's use another color here, green, for example. And for this angle, you got 78, 1720. So that's the second angle. So if you looked here, and also when you went to 111, you will measure the distance. But let's now focus on the angles. So these now are our angles. Let me share the desktop. Okay, so these are the two angles here. I'm sorry, just working with the different windows. to get it in front of you. So these are the measurements. Okay, so these are yes, somehow it doesn't show both. Okay, so it wouldn't show both the whiteboard and the measurements. But these are my measurements at 101. You see the 24 seconds and the 20 seconds. I just averaged that. I just averaged these two. So these are the measurements here. And if you look at the spreadsheet, this is what I have here. And then I moved to 103. I got two angles, the one in yellow, the one in red. And then I averaged that. Same thing with 105. I got two measurements. I averaged that. It might be better that you get your data out of the field notebook and put it in a nice spreadsheet. And you can use a spreadsheet for some of the calculations here. And then same thing. And I can share the spreadsheet with you. I have no problems with that. So this is the first, this is the second, and this is the average here. And so on. Okay. Having done this, also the distances. I have the distances. Let's zoom to the distances here. So these are my distances for the first, for the second, and then the average here. And I'm just here confirming the average, but you don't need this really. These are the averages here. If you look, these are the averages. Okay, so these are the data I collected in the field. Next, I'm going to show you how to do the adjustment. Okay, so I just edited the spreadsheet here. So hopefully now you can enter, since I told you I can give that to you. So now you can enter your measurements here for the first trial, the second trial, and then that will compute your averages. But again, double check with the calculator, because there might be some special cases if you are above, if one of the angles is above 0 and the other one is below. As for example, if you have this case 41 0 15 and the other one is 40 59 51, it does work here, but again, just double check these cases with your calculator. But in general, this is how it should look like. Okay, so this should show you how to input your data, how to do the calculations. Now I'm going to go here to the second part. So before doing that, this is our traverse here. I plotted the traverse in CAD. This is our final numbers here, distances and angles. So now the question is, how can we adjust this traverse? Do we need to adjust first? Let's take a look here. So we go back to our compass rule. So this is what you will see here. Okay. Yes. So the first thing, let me focus on the very first part here. I'm going to zoom in. So these are the measured angles. These are the measured angles. I don't really like using spreadsheets, but you can just delete. Okay, let's hide this. I don't want you to see this for now. Okay, so this is here the measured angles. These are our measured angles, and according to what we learned in the lectures, we add them all up. So I came with 719 degrees, 57 minutes, 150 seconds, which is, if you transfer that, that's going to be 30. And then you actually carry first the 120, which will make 2 minutes. 59,719. Again, if you do not know how to do that, you can do it with your calculator. Okay, so this is the sum here. This is the sum. Are we exactly 720? Why 720? Because we have 6 points here. So 6 minus 2 times 180. So we are off by 30 in this case. So I need to do the adjustment. Here is how you do the adjustment. So I have the sum here. And as I showed you, we are below 720. So negative 30. That's the error. The corrections should be positive 30 seconds. So we should add to the sum 30 seconds any way we'd like. No. In the lectures, we decided that we are going to adjust evenly among all stations. So that's why each station is going to take part of the 30. So 30 divided by 6, that is 5. So that's how much you will get that. This part here, I just put it without making it to be calculated, but maybe I'll try to work on it to make it calculated. So I just did some modification here to my file. It should work with you guys if you have your errors in second. So I just had the notes for the calculation, and then these cells are computable, so you can compute it. So what I did is just have the sum of the angles, and then out of this you subtract 720. So that's the angular miscue or the angular error in second in degrees, and this is the correction. Just flip the sign and then distribute it among all of them by dividing it by 5, and by dividing it by 6, you get a 5 here. Correction of positive. Now this should work if you have your errors in seconds. Now in minutes, I'll have to check if it's going to allow us to do that in minutes. And once we do this, so that's a correction in seconds per point. Now you come here and just add it to each one. So what I did here, which is something I assume we all know how to do, very simple. You have the angle, you add the 5. Since the correction is positive, we got the angles all jumped up by 5. So 5 seconds. So 78, 17, 22 will be the same degrees, same minutes, but 27 seconds, and so on. And then I added all of the angles. I got my 720 here. I got my 720. So that's simple. I think we can all do this. There should be no issues with computing angles and angle adjustments. Very simple. I prefer, or I recommend you guys what to do to make your life easy. Use a spreadsheet. Make sure only when you do the spreadsheet calculations to convert the degrees or the degrees, minutes, seconds into decimal degrees, and then backward, so you know how to do the add, subtract, or the calculations there. Okay. So I just did a quick check here. Even if you have errors in the minutes, this spreadsheet should work. Maybe I'll also make another copy, a clean one, where you put your numbers and you should get your measurements. But I prefer that you do it by hand, because eventually you will be tested on that. Eventually you will be tested on that. You will be tested on how to do the traverse computation. So please make sure to do it by hands also. So now we are done with the angular part, or the adjustment of the angles. Now the sum is 720. We're good, which might be different than the numbers. Here's another important thing. These numbers that you will see here might be the adjusted ones, might be different than the ones I have in CAD. So if I can get my desktop here, these numbers are different. So here, for example, I have the 78, 17, 28. I got it 78 Okay, hold on. 78, 17, 28. Adjusted is 78, 17, 27. So don't let this confuse you. Let's call these the true, although they are not true. These are measured, let's say, with the GPS. These ones are after you adjust. By the way, we don't measure the angles and distances with the GPS. We measure the coordinates and I plot them in CAD, and then I measure or compute in CAD the angles and distances. Okay, but these are the ones we got from a GPS survey. So even if they are different, that's fine. These are two different techniques. But of course, if they are like different in degrees or minutes, you have to be very careful here. But don't let this confuse you. Yes, we might get different numbers than what we have here. Even if the CAD one was measured with total station, that's a completely different survey. So please don't let this confuse you by any chance. Okay, so now let's see what we have next. Next, we have the lines. These are our lines. I'm going to assume that the first line, let me highlight that, is 30 degrees in azimuth, which is 101, 103. So if we look here at 101, 103, I assume north is in this direction, going up, and 101, 103 will have an azimuth of 30 degrees. Our next step is to compute the azimuths of all the other lines using the adjusted angles. I highlighted that or emphasized that. Do not use the measured. When you do the azimuths, use the adjusted angles. Otherwise, your azimuths will not close. Your azimuths will have an error. Okay, so the 30, this is what I have. I have it here in degrees, minutes, seconds, and decimal degrees. And then we all learned in the lectures how to compute the azimuth of one line from the azimuth of the previous line. So I'm going to show it here on the whiteboard quickly. So I have, oops, that's not a line. Come on. 101, 103 with an azimuth of 30 degrees. And the next line is 103, 105. That's a nice line to show you the concept here. The angle is 177, so a little bit, let's make it like this. I'm just going to make a little bit different here. So 101, 103, 105. So how do we proceed here? Let me get my pencil here. So this is north. And don't tell the professor is not drawing a straight line. I'm using the mouse here. This is 30. And this is 105. What is the azimuth of 105? What is this here? Here is how I will do it. You can do it with the equations, which is, write it down here, azimuth of 105. That's a big mistake. I did this on purpose. There is nothing called the azimuth of 105. The azimuth has to do with a line, so I have to say 103, 105 equal. And I'm just, so that you don't get confused here, maybe let me use something else. Maybe a hyphen would make it, let's use something that doesn't show, okay. That doesn't show you any operations here, any operation. So 103, 105 equals the azimuth of 101, 105 3, and I have to be specific. It's from 101 to 103, not the other way around. Plus 180 plus the angle in between, angle 103. Now let's substitute our numbers here. So what is the azimuth of 101, 103? That is 30 degrees, 0 minutes, 0 seconds, plus 180, plus the angle we have here. And I'm going to get this angle, again, the adjusted angle. And that adjusted angle, I'm just pulling it out of the spreadsheet, is 103. So that's 177, 1453 degrees, minutes, seconds. And then you do the math here. And after you do the math, of course, you do the math, this is going to be a little more than 360. So you'll have to subtract 360 out of the answer. And the final is 27, 14, 43 after subtracting 360, because this is more than 360. That's how you do this one. If you'd like me to do another one, I can do this. Let's say the next one, azimuth of the next line, that is 105 to, that's maybe a better symbol here, to 107, equal azimuth of 103, 105 plus 180 plus angle that I'm working with, which is angle 105, because I'm going, see, the angle is the angle between the two lines is just the common angle. So the common letter, label, number, whatever you have. So the common here is 105. Let me get some space here. Okay, angle 105. So now we substitute our numbers that equal 27, 14, 43 plus 180 plus the angle 105, which is, according to what I have here, making sure, 77, 13, 44, and then you do the math. That equals, from this to this, 284, 28, 27. Hopefully I did the math. Well, I'm just copying, I'm not doing the math, but hopefully I'm copying the numbers right here. But I think that is correct. And so on. You keep applying the same equation. That's how we do that. Again, I have the spreadsheet. I discourage you from using the spreadsheet, actually. I encourage you to do it by hands, because this is what you will be asked to do in your exams, or the FE or the FS exam. So if you know how to do it with Excel, that wouldn't help. But you can use it like to double check your numbers. Oh, I didn't share the Excel here. So these are our azimuths. I have them in both decimal degrees and degrees, minutes, seconds. Again, please try to do it by hand. Distances are in feet. Very simple. What I did is just took the averages here and copied it here. But again, you guys should know how to do averages of distance. That's a gift question if you have it in any exam. Okay. The next thing is to compute latitude and departures. So let me move this out, get back to my whiteboard, and clear this all. So clear all. and then get our axes here. Remember, we don't have something called X and Y in surveying. We have easting, northing. And then we have a line here. What you guys used to call the X component or the horizontal component, whatever you called it, we don't call it anymore this way. We call it the departure. And whatever you were calling the vertical or the Y component, we call it the latitude. And remember, our angles are measured from the north direction, our azimuth is. So this is here the azimuth, which means your departure equals the length times the sine of the azimuth. And don't worry about the signs, put the signs as they are. And then your latitude equals the length times cosine the azimuth. So that's what you need to do in the next step or few steps. Getting back to the spreadsheet here, I'm just using the spreadsheet to make sure the calculations close. This is what I did. I have the length, and then I did the latitude, longitude. When you use spreadsheets or most calculation softwares, make sure just to convert, if they require, which like spreadsheets or Excel require that, your angles to radians. So that's what I did here. I have the distances, I computed latitudes and departures. So these here are all latitude departures. And then we sum them up. And they should close to zero. And I think all the instructors here taught you how to do this here. You sum them up as they are, and they should add up to zero. If they did not, then there is a linear misclosure or a misclosure in the distances. We'll figure out now how to fix that. But this is what I did here. I just added these up. So maybe if I give you this spreadsheet, what you can do is maybe double check your calculations. Like you can maybe have your latitude, departures, and double check these different parts. And then we have the corrections now, or sorry, we have the errors. So we need to correct. And remember, you have an error, you correct by changing the sign. So in this case, if I have negative 0.7, the correction should be 0.70. And for the 0.31, it's going to be negative 0.31. So I flip the sign or switch the signs here to do the correction. And then distributed proportional to the length of the lines. So this one here will get the negative 0.7, but switch the sign. So 0.7 divided by the total length multiplied by the length of the line. Let's see that. Okay, so correction for line AB equals and then let me get line here and just preparing the math here. And then we write here. If you would like to write it, you write the negative of the error. And we are talking about the latitude. So error in latitude. negative the error in latitude. So this is the correction. If I wrote it here for the latitudes, so you have the error here, which is for your sum, which is your negative 0.7. So when you adjust it, it's going to be positive 0.7. And then sum of the lengths. And then you multiply this by the length of AB. That gives you the correction. Let's plug our numbers here. Equals. Let me draw a line. And then negative of the error. So that's negative. And I'm putting it here to make sure I have the two negatives. Sum of the lengths. So this is here 1099.09. And then you multiply this by the length of AB, 136.60. And then that equals whatever you will get here, which I have the 0.0866. That's the correction for the latitude. For the departure, do the same thing. So for the departure here, let's write it down. Correction for departure of AB equals and then same way it will be negative the error in the departure divided by the sum of the lengths, and then you multiply this by the length of AB. And then you substitute. So negative the error, let me what is the error in the departure? Hold on, I think, yep. Okay, great. I thought I switched the sign. So the sum here is 0.31, and then the sum of the lengths will be the same. So it's 1099.09, and then you multiply this by the length of the line, which is the 136.60, and that should equal your correction here for the departure, which is negative 0.038. That's it. And you do the same thing for the other ones. So hopefully that illustrates the concept here. Now, going back to the spreadsheet, we did do the corrections for the latitude and the departures. And when we sum them up, they should be the same value with the negative, or the same number with the negative sign here. So that's why you see these switch. The negative 0.7 is now positive 0.7, and the positive 0.3 is now negative 0.3. What we do now is we add the corrections as they are with the sign to the latitudes and departures, and that's why we change the sign. So this cell here is just adding the latitude as is with the correction. That gives you the corrected latitude. So to illustrate this, let's say the latitude equals 100.05. Your correction is positive 0.04, So corrected latitude equals those 100.05 plus as is the 0.04, which is the 100.09. If the correction was a negative, if the correction here was a negative, then the corrected latitude will be a little less. So you just use the same sign here. That's what I did. Okay. After we do this here, we got the corrections, we got the latitude departures, they corrected, they should sum up and add up to zeros as the latitude, zeros as the departures. Now, let me show you what happened here. So you had a line, and this line had a difference in latitude or latitude, difference in northing, departure, difference in easting. That's how the line was. What you did now is you adjusted this line. So after adjusting the line here, your new line might look something like this. With this line here, the departures and the latitude have changed a little bit. So now we need to compute the new departures latitude. And how can we do this? Well, we will do this here by Pythagorean theorem. So that's the next step. So now I'm going to write this here as corrected. Well, I don't like the word corrected. It should be adjusted more, but corrected length equals, and then I'm going to take the square root of the we might run out of space here. Corrected latitude squared plus corrected departure squared. So that's what we did here. That's the corrected distance. That's adjusted distance here. This is the square root of the latitude corrected plus the corrected departure, so on. The other thing that happened also, if you noticed, my sketch here is back to my sketch here. The blue line here, which is the original line or the original latitude departure, had a bearing. That was the bearing of this line. And we did see in the lectures the differences between bearings and azimuths. So I'm not sure why it doesn't want to get this freehand. Okay, so this here was our bearing. But now after the adjustment here, if you look at the line, it's not going to be the same bearing because the latitudes departures have changed. So if this is still north, our latitudes departures have changed. These two angles in blue and red are not the same. So now we need to make the new, or we need to compute the new bearing. So remember here, with bearing, if this is our directional sketch here, so the line is in the first quadrant here. It's going to have a bearing of north, a number east. If it's here, it's going to have a south, a number east. And then here it's going to be south, number west. And here it's going to be north, number east, west. And in the first quadrant here, latitude is positive, departure is positive. Here, latitude is negative, departure is positive. Here, just making sure I'm showing this, latitude is negative, departure is negative. Here, latitude is positive, departure is negative. That's how the latitude and departure are related to bearing. So what you need to do here is look at your latitudes, departures. I didn't get yet into calculations. Calculations should be simple and easy. You look at the latitudes, departures, and figure out first which quadrant you are in. So let's look at this. I didn't yet go to the numbers. The numbers are arctangent, that's fine. But let's take a look at the thing that is most confusing here, which is the quadrant. Okay, so now we go to the compass here. Let's look at these. These two are positives, so northeast. Great. Positives, northeast. Let me highlight them in colors here. Northeast. Positive, negative. I'm picking another one. Northwest. So latitude is positive, meaning north. Departure is negative, meaning west. How about this one? Latitude is negative, so south. Departure is positive, so east. And so on. That's as simple as this. Okay, so that was simple. Now, how about this number here, which is the angle or the bearing value? How can we compute this? This is very simple because we do know that if I draw this here, bearing is this angle, whether you compute it for this line or this line. Change the color. It's the opposite, it's the arctangent of the opposite divided by the adjacent. So the opposite is always going to be the departure, and the adjacent is always going to be the latitude. So that's how we do that. So your value here, bearing okay, bearing angle will equal the arc tangent what is the opposite? It's the departure. And divided by the latitude. That's the bearing angle. And then once you do this here, just make sure when you do that, since you already have defined the quadrant, to make it with the absolute values. So you just get the small value here. just use the absolute values. This way, you guarantee that your angle is going to be from 0 to 90. Otherwise, you'll need to do some calculations and take care of the quadrants, but that's what I did in my spreadsheet here. So these are the values here, just by taking the arctangent here, which we all did before. And then I converted this into degrees, minutes, seconds. And that's it for the adjustment part. Now the next part is going to be if I got this here, computing the coordinates here. So let's assume here that I have this is my traverse here, or let me maybe make it a little better. Maybe like this. Of course, it's close, but with the mouse, that's the best I can get. And then I have A, B, C, and so on. Now, if you put this on the grid here, this is your east direction or easting. This is your north direction or northing. Let's assume I have a coordinate for A here, which is 1,000 here. And you have the latitude and departure. So you have the latitude, I need to change color here. The departure and the latitude. Our next step is what are the coordinates of B? And that should be simple, just by adding the latitudes departures here. So you can say northing of B equals northing of A, and I'm going to put the subscripts here, plus, since this is northing, so plus the latitude of AB. Let me just write the subscripts here. So this is A, the point before it, and this is B. And then same thing for the easting of B equals the easting of A plus the departure of AB. If you looked here, that's what I did. We have the first point. I assumed the first point to be 1,000 and 5,000. So all groups could use this number here as an initial start. Assume the 1,000 for the northing and the 5,000 for the easting. And then from there, you start making the other points. So the northing here will be the 1,000, which is the 101, plus the difference in the northing coordinate, which is the latitude of the line between both. Same thing for the easting, and so on. That's what was in the whiteboard here. That's what we did here, this thing. That's this part. The last part here is what we call the relative precision here. And with the relative precision, we need to know how precise our traverse is. And to do this here, that's what we are going to do. We are going to do two things. First, let me clear this here. The first thing is I compute what we call, I'm just trying to see if I should, okay, the misclosure here, or the linear misclosure, which equals the square root, and I'm just putting the signs here, pluses, or plus and squares, and then the parentheses, and this is the sum of the latitudes, which was the error or the correction of the distances in latitude, and the sum of the departures here. I'm hoping this is shared. I'm not sure why it's showing it's not shared. Okay, and the sum, whether you put it with positive or negative, it doesn't really matter, because at the end, you're just squaring that. So this is what we call the linear misclosure, which is what we are referring to in the spreadsheet as the closure error. Once you compute this here, then you compute your relative precision. Then you compute your relative precision. So your next thing will be your relative precision. And that is the following. This error misclosure that you just computed, or the linear misclosure, same thing. If you want to use the same term, the closure error divided by the sum of the lengths. So let's do this for our case. In our case, our linear misclosure, which is the closure, let me just write it like this, error, equals square root and then we have the 0.7 square. I didn't put the negative, that's fine, because I'm going to square anyway, plus the 0.3 square. If you did the math, according to the math I have here, that equals 0.76. And then you divide this here, so you get your relative precision equals the 0.76 divided by the sum of the lengths, which is the 1099, and then you can put the 0.09, and that's going to give you a very small decimal number here. So what you do next is you get the inverse of that. So you put it in a ratio format, which is 1 divided by the 1441, which is approximately 1 to 1500. And this is 1, by the way. So if you did the math here, you get a very small number for this here. That's going to be like 0.00 whatever. If you want the exact number for this case, this is going to be 0.00069, but you get the inverse of it. And that's what you will end up having here. So that here shows you how to do the calculations for this particular traverse.